So hello everyone. Today we are going to be understanding arrays. So a array is a collection of data of similar type. So suppose we have some numbers like 1, 5, 6, 7, 10. So this number is a collection of data, and of course the type is a numbers, integers. So if we put them in a continuous space in our computer memory, then that space will be called as array of integers. So this is array. We can put it like this. Now to access any element in the array, all we need is the address of this element. Then we can easily calculate the address of any element in the array using its index number. So indexing in array starts from 0 like this. So all these blocks of memory are numbered like this. Suppose I want to know will be the address of index 3. So that means what will be the address of this box in memory. So that could be easily calculated uh, because we already know the base address of the array, which is the address of the index 0. So its formula is something like this: base address plus, we don't have to necessarily know this, but I'm just telling so that you know. Base address plus, it is like size of one element. Here in this case it would be int, so I will write int uh, times index. So suppose the base address is 1000. We know that size of int is 4 bytes. So this would be 1004 address because it is stored in a continuous manner. So and this would be 1008, and this would be 10012. So this would be 10012. 1012, sorry. So now base address, we can also confirm that using this law that this is correct. So size is 4 into index is 3, so that is 10. So yeah, this formula is correct. What that implies is that if I know the index of any element in the array, I can access that element in constant time, meaning all I need to do is apply this formula and I will instantly know what is the address of that index in the array, and hence the access time complexity of any element in the array, if we know its index, is constant time, because we are doing is using just one statement, find. So with this constant access time, So that's pretty much about the theory, I guess. Also, so when we need to decide what will be the size of the array, if it's a like a static array, we need to predefine the size, and it will not change during the execution of program. So we need to predefine the size of the array. So size is fixed. Of course, there are some other data structures like dynamic arrays, but they are uh, topic topic for some other time. We will not go into that now. For now, we can think of arrays as fixed size, continuous memory allocation, which can store data of same type. Uh, Now I will show how we can implement that in C language. So you can ignore this part. This is not important. It is just meant for input output, and you don't have to write it in your code if you are using some other editor other than Sublime. And even if you are using Sublime, you need to first of all make the similar setup as I have and then use it. So anyways, first of all we need to write the data type of our array. So I'm telling the syntax of arrays in C language. Then we need to write the name of array, uh, and then we need to specify the size like this. So suppose I want a array of integers, then I will write int that will be the data type, and then I will write the name of array. So let's say name of array is C. Then here I need to write the size of the array. So let's say the size of the array is 4. So this was the syntax. We don't have to write it. So that's how an array is declared in C. Now to put the value in any of the locations, like what this line will do is make allocate 4 continuous boxes in the memory which are capable of storing integer data type. So something like this. So now indexing in array starts from 0 as we have already discussed. So this will be the indexing. So right now the array is just declared, meaning we did not put any values in it yet. To put values in the array, we need to know at what index we want to put the value at. So if we want to put suppose value here in this box of the array in this location, then we need to know this index. So suppose I want to put a 0 here, so I can write so first of all write the name of the array, then put in square brackets the index of the array. So remember that this was the size of the array, meaning how many blocks of memory we have allocated in our space. That is 4. But when we are putting or accessing values of the array after declaring it, then here it refers to the index of the that location in the array. So if we are writing like this, we are referring to The index number 2, that would be the third block of the array because indexing starts from 0. So I can write C2 equals to, let's say, 0. That will put a 0 here. Suppose I want to put a 9 here, then I can do is put a 9 here. Sorry, indexing starts from 0. So the first location would be index 0. So what I did is C0 equals to 9. That will put a 9 in the first location. Now suppose I want to access the elements of the array and I want to know what is there. So I can print them to know what value is at that location or at that index. So we need to of course specify the type. So let's say I want to know what is at the first location, first index, index number 0. So now let's run it. So interesting, it is printing nothing. I think it should have printed 0, but okay, so the file name is incorrect. So the file name, yeah, no. Anyways, ignore that. Yes, so it is printing 9. Yes, so at index 0 we have put the value 9. So and then we checked is what is the value at index 0. So it is indeed 9. We can also check what is the value at index 2. It is 0. No, notice that we have put the values at index 0 and index 2, but we did not put any values at 1 and 3. So what if I type 1 here and check what is the value at index 1? So I expect it to print any garbage value because we did not define any value to be there. So it must be anything random. See, 52. It's just garbage. It could be anything. Only values which we have defined mm, can be trusted, I can say, in while we are calculating. If uh, value at some index is not defined by us or during runtime, then it can cause problems sometimes. So that is about it, about 1D arrays. Yeah. Now we can look into 2D arrays. So let me erase this. Yeah. Sorry for bad drawing. Actually, I'm not very good at drawing. So 2D array is just nothing but, in a sense, 2D, meaning that we just add another layer to our one dimensional array. Previously, we only had like this, but now we have like this in memory. Previously, we are allocating memory continuous space only like one row, but now we will have many rows. Or another way to look at it is many columns, of course. all of them are in uh, sorry all of them are continuous, and there is no gap in between them in the memory. So access time here is also constant because there is a formula to calculate any index, calculate address of any index in this 2D array if we know the base address of this 2D array. So here indexing is done in a different manner than 1D array. It is like starts from 0. So let me draw a simple 2D array first of all. Yes. So it is like coordinate system. You must have seen coordinate system. We have x-axis and y-axis like that. It is quite similar to that. So it is done like that. So we of course start from 0 in 2D array also, and then we keep increasing the count as we go through different rows and columns. So index of this memory will be 0 comma 0, like we used to write in uh, coordinate system. 0 comma 0 is the coordinate of course this is not a point but a memory block. So and this will be 0 1, this will be 0 2, and for example let's say this one will be 2 4. So the first number specifies the row number, index of the row, and the second number specifies the index of the column. And remember that indexing starts from 0. So if index is 2, that means it is referring to the third row of our 2D array, and if index is 2 comma 4, third row, and fifth column of our 2D array, that with this memory. Now coming to the syntax part of 2D arrays. So as in case of 1D array, first of all we write the data type of our 2D array. It could be integer 2D array, character 2D array, whatever you want. So then we write name of our 2D array. Then we specify the number of rows in first square bracket, and then we put another square bracket and specify number of columns in this square bracket. So here we write number of rows, and here we write number of column. Okay, so I'll show how it's done. Int is the data type of our array, let's say, and let the name be a, and let's say the number of rows is uh, 5 and number of columns is 4. So this will create a 5 by 4 matrix in our memory, computer memory, and then we can use it to store integer data type in values of integer type. So let's say I want to, so okay, ignore the size of this, but let's say I want to uh, store at location 1 1. So this is 1 1, right? Second row, second column, index 1 1. Okay, then what will I do is I will write 1 1. So here we are accessing this location. So this is the index of row, and this is the index of column, and This was the size of, meaning how many rows were there and how many columns are there. Okay, so and I can put some value in at this location. So a 39 will be placed in this location, which can of course later be accessed in a similar manner using index of row and column. So that's all about, I suppose that's all about basics of 1D and 2D array. Uh, yes. Now what else? What else? So now I can, yeah, that's about it. Thank you for watching.